A new quantum era is unfolding, one where materials and devices engineered at the atomic and photonic scale will shape the future of computing, communication, sensing, and security. To lead this transformation, Department of Science and Technology, Government of India, under the National Quantum Mission, has established the Quantum Materials and Devices Thematic Hub at the Indian Institute of Technology, Delhi. QMD Foundation is India's national platform building the dedicated foundry for materials, photonic devices, detectors, and semiconductor-based hardware, enabling quantum computing, secure communications, and ultra-sensitive sensing technologies. As a non-profit Section 8 company, instituted by IIT Delhi under NQM, the QMD Foundation brings together academia, industry, startups, and national labs, forging a truly collaborative and innovation-driven quantum ecosystem. At the heart of QMD Foundation's mission are three national technical groups, each pushing the frontier of quantum device engineering from different directions. At IIT Delhi, Professor Rajendra Singh heads a major national effort to build on-demand single-photon emitters, single-photon avalanche detectors, high-frequency nanowire devices, and advanced semiconductor-based quantum components, leveraging state-of-the-art gallium arsenide and indium phosphide technology. Supported by a distinguished team across IIT Delhi, IIT Bombay, IIT Roorkee, IIT Kharagpur, SSPL DRDO, and IIT Madras. This group is enabling the fundamental devices required to process, generate, and detect quantum information at the single-photon level.
Under the National Quantum Mission, we will be setting up facilities which will be used for the growth of high quality indium phosphide and gallium arsenide based materials. And these materials will serve as the platform for the fabrication of single photon detectors and single photon emitters, and also high frequency, high electron mobility transistors. Even other groups who are working and who are looking for these high quality materials, the material will also be made available to those groups depending upon their application. So one important thing to mention here is that this quantum materials and devices hub will span across the other three hubs like quantum computing, communication, and sensing and metrology. So the materials technology as well as the device technology that will be developed through the QMD hub will be made available to these three hubs so that they can use it for their particular applications.
Meanwhile, at IIT Kharagpur, Professor Shailendra Kumar Varshney leads efforts to create reconfigurable and scalable photonic qubit architectures, built through both heterogeneous and monolithic approaches, enabling quantum photonic processors that can be designed, reprogrammed, and expanded with ease. His team draws strength from experts at IIT Bhubaneswar, IIT Bombay, and IIT Roorkee, each engineering photonic platforms capable of powering next-generation quantum communication. At IIT Bombay, Professor Saurabh Lodha leads groundbreaking work to create wafer-scale emitter and detector arrays that operate at room temperature and across multiple wavelengths, unlocking practical photonic quantum technologies suitable for real-world systems. Working alongside collaborators from Indian Association for the Cultivation of Science, Kolkata, ISCR Pune, IIT Kanpur, IIT Kharagpur, and IIT Delhi, this group is pushing the boundaries of scalable manufacturing and quantum photonics integration.
As part of the National Quantum Mission that was launched last year, I'm leading a project for 6 institutes and 13 faculty, which will deliver single photon sources and detectors for quantum communication technologies. Specifically, my research group is going to build single photon detectors. We have been working in this area for the last several years. We have built multi-photon detectors in this lab that you see here. But in this project, we will scale it down to a single photon detector. The single photon detector that we will build under the National Quantum Mission in our lab will help push quantum communication technologies in the country. Specifically, these will enable highly secure communication where there is no chance of the information being lost or stolen, And this will really put India in the League of Nations, very few nations who have access to this technology indigenously. We plan to prototype chips based on 2D semiconductors for single photon detection. If successful, this would be the first of its kind globally, and we eventually plan to launch a startup to commercialize this technology in India.
By designing and synthesizing next-generation quantum materials, including novel semiconductors, topological materials, superconductors, and integrating them into quantum devices, QMD is laying the material and device-level backbone for India's quantum-safe future. Moreover, through its startup support initiative, Next Leap, QMD invites innovation from entrepreneurs, offering funding, mentorship, prototyping infrastructure to translate quantum research into real-time products and scalable technologies. With world-class fabrication and characterization facilities, multi-institution collaboration, and support from government and industry, QMD Foundation aims to transform quantum science in India from labs to real-world quantum technologies, from photons and electrons to revolutionary materials and quantum technologies. QMD Foundation is shaping India's quantum future brick by brick because the quantum revolution won't wait. And now, India is ready.